skip the entire loop and end up on post 23 as 201, right? But that's only one way, because x equals 201 minus 53 has to be a component of pre-21 as well. Because if x equals to 201 minus 53, it is what? 158, right?
148.
148. So if x equals 148, then it will get into the loop, execute, x gets x plus 53 exactly once, go back to the condition, and then exit right away. But by that reasoning, then we can say x equals 201 minus some number times 53 has to be, okay, well, I should say, make it more clear. So we'll pick a value. I'm just trying to pick a, n is good, thank you. Be a component of pre-21 for all n equal to 0 to infinity. Okay? In other words, x can start with negative, just pick some really large n value, and then you just say, what if x equals to 201 minus some really huge integer times 53? Well, it just has to go through a few more iterations, but it will get out of the loop with x equals to 201. Okay? So in this case, there's no way you can enumerate all the possible values. All you can say is that x has to fit a particular pattern. X has to equal to 201 minus n times 53, and n can be any non-negative integer. That would be the answer. Yep.
In this case, we go out of the loop with x equals 200, and if x goes down, we get 201.
Yeah, but I already told you what post 23 is. I told you that it is exactly that. So even if the post condition is that exact and that specific, the precondition of the loop is still infinite in terms of possibilities, because this is a loop and not a conditional statement. Okay, so this is not, I won't ask you a question like that in the final exam. Okay, I might give you nested conditional statements, but nothing like this. Okay, so in this case, the proper description is to say that pre-21 equals to, okay, x is, I'm just trying to find out what is the best way to express it in the context of this class. I know how to express it in the context of CISP300, but
Express it that way, honestly.
Honestly?
Yeah.
Okay. So in that case, x is in the set such that y equals n 201 minus n times, what is it, 51?
The x or
What?
You're right.
Yeah. For n, for all n,
Positive integers.
yeah, for all n is a natural number. That would be the way I would express it, using the proper, element of and all that stuff. But this would be the proper way of expressing that statement. Is that x is in the set. Okay, this is a set set notation, and the set consists of of all y values such that each y is 201 minus some n times 53, and n is a natural number. But that's like way beyond the scope of this class, using the set notation. So for a class like this, you just have to say that it is expressible in the form of 201 minus some non-negative integer times 53. And as long as you guys know that there's an infinite number that can fit that pattern, that's good. Okay? So you can see, how loops, can throw a big wrench into the process of debugging, because, you can backtrack assignment statements pretty easily. You can backtrack even conditional statements pretty easily, but backtracking loops gets a whole lot more difficult if you just know what is the state after the loop. Getting back to the state before the loop is very, very difficult. Yep, go ahead.
So we should not have x or x equal to 100 or we should not have that.
Because that cannot, there's no way for you to enumerate all the possible values.
Other than the possible values that we have that contains negative n times 53. Other than that, we should not have something that says or x equal to 101.
Well, that includes it, because n can be a natural number, and natural numbers include 0. Well, that's why I said, this is not right in the context of this class, because you have to first understand what is a natural number, because natural number is the set of non-negative integers, 0, 1, 2, 3, 4, and all the way up. That's the natural number set. To write this, in the actual mathematician way, you basically say that x is an element of the set, such that all elements in this set can be expressed as y, such that y equals to 201 minus n times 53, and n is an element of the natural numbers, and that's how you write the natural number, in mathematical terms. But that's not the right context for this class. How many of you are looking forward to CISP300? It's actually not a bad class. It's just a lot more math than programming in that class. But I think it is very important for any programmer to understand more about mathematics. What we are doing in this class is a good introduction to the formal or the rigid portion of math that is applicable to programming. Calculus, for instance, is not really directly applicable to programming in general, but yet it is a prerequisite of most computer science programs. Can anyone guess why that is the case?
The languages are similar.
Yep.
You don't develop better problem-solving skills.
Better problem-solving skills, but they could have required, say, abstract algebra, which actually does relate to computer science a little bit more, or Boolean algebra, something like that, discrete math that is more related to programming. I think calculus, historically is a prerequisite to the computer science program, because in many schools, the computer science department is actually a spin-off from the mathematics department. And possibly a lot of the problems in the early days that they need to solve are actual numerical problems that they have to solve. So that's why numerical analysis and many branches of math from calculus are actually useful in early day computer programming. But in these days, we don't really deal with a lot of those problems anymore, and that's why calculus seems to be not directly related to programming anymore, even in a computer science program. I believe so. I believe it is more historical than anything else. It's like, over here, just a few